We have the next session, Adrian, going over the state of ofproto trace, how to use it, and what are the missing parts. All right, thanks, Adrian. Take it away.
Yeah, thank you. So, are we? Yeah. Okay. So, yeah, this is a lightweight session. I wanted to share with the community. This is an idea that I've been exploring whenever I have some free cycles. I haven't had many of those lately, so I don't have anything solid, just ideas, challenges, frustrations that I'm going to share with you all. Hopefully, this can trigger hallway discussions and I can get some feedback from you all. So the motivation is simple. ofproto trace is an awesome tool. It gives you all the open flow context, but also like internal values of the like the metadata values and register values as the open flow pipeline is evaluated. It is essential for debugging, and it also helps you connect with higher layer like controllers like OVN, but it's offline, and that is a bummer because that means that everything contextual, such as connection tracking information, is not reliable. And nowadays, connection tracking is pretty much everywhere. So, well, there's also another problem, which is, I guess, nitpicky. Typing the flow into ofproto trace is a bit cumbersome sometimes. But the main problem is it's offline. And I would really love it to be live, like on a real packet. So I started exploring. I looked at how ofproto trace is called. You see the function where we run ofproto trace. It's really just populating a tracer or a trace object, which is at the end dynamic list and a dynamic string, and put it into the input as input parameter to the xlate actions function. The xlate actions is the same function we call during an upcall or during revalidation. So first thing I try to explore, or rather hack my way through, is okay, how about we just add this or a wrapper around this object into the upcall struct. So early on, we can decide if an upcall shall be traced or not. And if we decide we should trace this upcall, we just add this object here, and that's it. We just at some point we call xlate actions with it, and we should get the information, right? But we don't want to trace every single packet, right? So we need a filter. Luckily, we, in vSwitch, we have this awesome flow syntax, so we can. So, I mean, the next idea that I thought is, well, maybe we could add a filter. Like we could say, I want to trace every IPv4 packet with that source IP address, and that would be it. Then an idea came up, like, could we have a USDT probe implement the filter? Like something like BPF original intention, like packet filtering. That's it. Yeah, that idea quickly went away because it's returning information from a USDT probe is hacky, to say the least. But then there's this challenge that I faced: how to return the information to the user. First thing that I thought is, well, we could just dump it to the logs, but as we'll see, this is also problematic. The log gets very dirty, and there's interleave of log messages. So it's not ideal. It's far from ideal. We could store the resulting string some like in this struct, and then just return it with another OVS upcuddle command. But the object lifetime also gets more complicated. And finally, another approach would be to have USDT probes emit this information. Again, a lot of challenges here, mainly if you format the string in OVS, then it's cool, it's easy, but you pay the cost of formatting. And if you don't format the string, you just pass a binary object, like an internal struct, to the USDT probe. And in that case, the eBPF program that you attach needs to understand the internal OVS structs, which is a problem that we currently have, and we don't have a solution for. So I guess that's it. But then I thought, well, once we trace an app call, what if we could also trace the UDPIF key that app call creates? The UDPIF key is the internal object that we have in OVS that represents a UDPIF flow, a data path flow. So we could just add that object to that struct as well, right? And that is nice, but it creates even more problems. Lifetime management is significantly more complex because UDPIF keys live way. I mean, we cannot really control its lifetime. So yeah, really complex. And then the connection between the UDPIF key and the app call that it generated, it has to be done manually, and it's really, yeah. We don't have an app call ID, and creating one for this use case, it doesn't really make sense, I guess. And I'm also investigating like other approaches, like doing a USDT only based solution. This would be essentially not doing ofproto trace per se, but just at least logging each action that gets translated for each app call. It's a simplified version of ofproto trace, just based on USDT probes. It's simpler, but it doesn't give us all the information that ofproto trace does, and we would not have UDPIF key tracking. And I just wanted to show in this last 2 minutes a small demo of what I'm talking about. I don't know if hopefully you guys can see it. What I'm showing here is just a hack that I did. There is an OpenShift Kubernetes kind cluster, and my goal is to have something as easy as this, but not that hacky. Okay, so let's see if I type the command now. So in this case, what I've implemented is just a filter-based approach and dumping the information on the logs. So as you can see, I'm filtering on TCP SYN packets with a specific source IP address, which is the source IP address of a pod. I'm going to send a packet, start a connection, and what we'll see is the ofproto trace of that packet. What you see is the ofproto trace of that packet plus the logs of every revalidation round on all the UDPIF keys installed by that app call until eventually the UDPIF key gets deleted. So the cool part is you get the packet, you do the first chunk of ofproto trace. The packet gets sent to contract, recirculated, and you just keep the information that frozen state must be tracked once it's unfrozen, and then when the packet is thrown, you just continue dumping the information of that ofproto translation. So this is what I wanted to achieve. I'm looking at the logs, at the OVS logs now. I don't want to do that on the logs. I just want it to be consumable in a better way. But yeah, this is what I'm trying to achieve. I hope there are some better ideas of how to do it. Also, a good part of UDPIF tracking is you can check ofproto trace of all the revalidation rounds. So when a when a flow is evicted because the open flow configuration changed, you see the new open flow information. Yeah,
I'm going to grab you off stage. Yeah, there we go. Yeah. All right, thank our speaker. So if you have more ideas